Hey everybody, thanks for joining us. Before we start, I want to let you know that this activity is part of the Tattle Maker Fest, so we want you to showcase your work. We're teaming up with the Steam Maker Alliance of Northwest Michigan to kick off Tattle Maker Fest 2021. Normally, this is a big in-person event, but it's going to be a virtual event this year, and it's going to take place over several months. And this activity, this video, is the first activity of MakerFest. After you do your day and night activity, you can showcase it at the Steam Maker Monthly Showcase. This event is a fun way to show off what you learned and what you made, and families that complete an activity and the brief follow-up survey are going to be entered to win a monthly STEM prize pack and a drawing for the STEM kit of their choosing. So just go to tattle.org and click on events, and you can find the link for the monthly showcase, and there's a way to submit a photo or video there, and you can also join us live at that showcase. So we hope that once you're done doing this activity, you can share what you've done on there. And with that, I'm going to turn it over to Miss Ann.
Hey, hello everybody. And not only that, but just from doing these astronomy activities in January, the National Park Service put out this Night Explorer guide. And all the activities that we're going to do today are in this guide. And if you come and join our First Step Science every Friday at 11 this month and do the activities, you can earn a Night Explorer patch and then receive the guidebook to do even more astronomy activities. So I'm really excited about First Step Science this month. We're going to become night explorers. That is really exciting. Do you like to look at the night sky on a clear, dark night, especially this time of year? Go outside and it's cold and it's clear and it's crisp and you can see lots of stars a lot of times. I like to wonder about those stars. How many of them are there? Could I even count them all if I tried? What would they look like if I could take a rocket and get up there and get closer to them? What would they look like? I like to wonder a lot of things about when I look up into the sky. Have you ever seen a shooting star? One of the things I wonder about is, where did it come from? And how, in that great vast amount of space, how did it just come right here to Earth and burn up in our atmosphere? What are the chances? So there's lots and lots of questions that I have when I start to look at the night sky. And astronomy is the science that helps us learn everything in the universe. We learn about the moon, we learn about the stars, and the sun, of course, because it is a star, and planets and galaxies and black holes and supernovas and comets and solar systems, and I've probably left something out. I'm sure I did, but I'm so excited because there is so much to learn, so much to find out. And I hope you get excited about becoming a night explorer with me too, because you also get these two items if you do some of these experiments. So today, we've got to get right to it. Day and night, that's the topic for today. And that seems simple, right? It's dark, it's night, it's light, it's day, and you're asleep at night and usually awake and active during the day. But just to help us think about day and night, I have this book that I'm going to try to read quickly, and then we're going to do some activities together. This one is called The Sun is My Favorite Star by Frank Ash. And I'm going to turn some of the pages. There it is. The sun is my favorite star. Okay. Let me turn some pages. The sun is my favorite star. In the morning, it comes into my window and it wakes me up. Sunrise. How does that happen? While I have breakfast, it sends the mist away and dries up the morning dew. How does that happen? Then it waits for me to come out and play, and the sun is my favorite star. Do you play outside in the sunshine? I do. Whenever there's a sunny day, I like to go outside. Okay. Gliding through the trees, there it is, right above my head. Whoa. It follows me everywhere I go. Have you ever noticed that when you're walking outside? And it's like that with the moon too. Wherever you go, it seems to follow you. Why is that? It's like all great science questions. It peeks through a hole in the fence, and you can make shadows. Shadows is a whole nother interesting science project. The sun is my favorite star. Sometimes it plays hide and seek with me. Like behind the clouds? Yeah. Sometimes it goes away. Oh, on a cloudy, rainy day. Can't even see it. What's blocking the sun? And then it brings me back a bouquet. Now, what is he talking about? Maybe the bouquet of rainbow colors? We're going to talk a little bit about that later today with the project. Okay. The sun is my favorite star. In the evening, it paints pretty pictures in the sky for me. Whoa, sunset. So we went from sunrise all during the day and then sunset. Oh, I think we've got something going on here. Oh, and look, nighttime. Even in the nighttime, it sends its light to keep me company. How does it do that? Why does the moon shine? Another great science question. All the stars in the sky are beautiful. But so far, the sun is my favorite star. There we go. All right, so that's just to get us started and just to get us thinking about day and night. It is simple. It's just as easy as day and night. But think about the sun, and it's a star, and it creates a pattern of day and night for everyone here on Earth. You have the sun, you have it rising in the morning, and then there you are, daytime, and then sunset, and then nighttime, and it's a pattern of 24 hours. And we actually depend on that for life here on Earth. So let's find out, let's do a little experiment and find out kind of exactly how that might happen. So I have a ball, and I have a couple of balls, but I have a ball, and I have something to set it on, like a cup, just one of my disposable cups, and I have a couple of different flashlights. We're going to use this one, and then I also happen to have a globe that spins. You might not have one of those at home, but we'll demonstrate with that. And then I have another bigger earth ball, and we're going to try to make it shine day and night. Okay, so the first thing I have to do is turn out the lights. It's going to get dark in my den so that you can actually see my flashlight shine. Here we go. Okay. Whoa, you know what? I forgot that my computer is going to make some light. Whoa, so that's very glowable. All right, so let's pretend that that's the Earth. And there's your light source, my flashlight, and that's the sun. Let's turn on the flashlight and shine it at the ball and see what happens. Whoa. Now when I look at my ball, actually it makes my whole white ball glow. But can you see here out in space is the sun shining on the Earth. This side is light. And if I turn and look on the other side over here, I can't see the sun shining and it's dark. And you can almost see on my computer screen the line of day and night. Now what happens is the Earth turns and rotates. Let's see what that would look like with my globe. There we go. Okay, so I'm going to turn on a bigger flashlight and see if we can see the day and night better. So you can do this at home and demonstrate how the sun makes Earth There we go. Whoa, that lights up my whole room. Whoa, yeah, you can really see this better. So there's the sun in the sky, and it's shining on our Earth. The light's coming from space, and as it rotates, there we go. This is the day side, and this is the night side, and you can see here comes a sunrise, and then back over on the other side is the sunset. There we go. Very cool. All right, so I'm going to turn off my flashlight for a second, and I'm going to turn the lights back on because I'm going to do one more thing to show how it's really dark on one side of the Earth when it's night, and light on the other side where the sun is shining. Okay. Oops, my flashlight's still on. Ah! There we go. Okay, so here's my ball again. And what I have here is a spray bottle of some food coloring. And what I'm going to do is pretend that the spray from this food coloring spray bottle is light hitting the Earth. And my ball is kind of white, so let's see. I'm going to spray it from out in space. Here's the sun, and I'm spraying it. And let's see where my spray falls. I've got a little tray, because of course I'd make a mess. And some of the food coloring will drip, but let's see what happens. Okay, where's that light spray gonna hit our Earth? Okay, there we go. I'm spraying. There we go. Okay, so I'm gonna turn this to the screen so you can see what happened. Whoa! The day side where the light was hitting our Earth has lots and lots of, I'm going to call them light drips. And then if I turn it around to the night side of the Earth, check it out. No light from the sun hit back there. So you can actually take a look, if you do this at home, you can actually see a line where no light hit. No, I'm going to call it light drips, light paint. And all around there, there's a definite line. And if I had turned it, eventually, I could do day and light all the way around our globe. All right, so that's kind of a fun thing to do, to see what happens with day and night. And I'm going to put this one down. And we're going to do another activity. Oh, there we go. I'm going to put this away. And there we go. So besides being dark, what is the night like? Oh yeah, right. It's dark. You can't see the sun because you're on one side and the sun's on the other and the whole Earth is in between. What animals do you think you might see at night? Maybe owls, maybe bats. All of those animals depend on the darkness for their life cycle. What does the air at night feel like? Well, our sun is the nearest star, and its bright light is really amazing. It gives us heat, and it causes the water cycle. Do you remember from the book that I read that it dried up the morning dew? Yeah, evaporation, right? It makes it possible for life here on Earth, and light actually comes in waves and particles, and sometimes we call them rays, and our eyes can't see all of the light that comes from our sun. I mean, we can see a lot of it, but not all of it, because there's different frequencies that our eyes can't actually detect. So there's infrared light, which we perceive as heat, and there's ultraviolet light, which we can't see at all. But if you've ever gotten a sunburn, you know about ultraviolet light. Those are the rays that actually can damage our skin with sunburn. So there's those two that we can't see, but we can feel them. Infrared, we perceive it as heat. Ultraviolet, watch out for that sunburn. But do you remember the page in the book with the rainbow? We're going to explore why rainbows happen, because light comes in all different colors. And why is that? Well, light is a wave, and I'm going to illustrate that with a rubber band in a box. Have you ever done this? Stretched a rubber band over a box and then plucked it. You can hear the sound, and you can actually see the rubber band vibrating. It's sending waves of sound over there, and I can change the frequency by stretching it tighter. The waves get shorter, and I can stretch it again, oh, and make it even higher. So when the waves of light are vibrate at different frequencies, we see different colors. And I've got a little cup with some water in it, and when those waves pass through water particles, the light is refracted. And so if you can, I've got a bad reflection on this, but try this at home. If you get a pencil and stick it in a cup of water, the pencil actually looks broken because the light is hitting the water and bending or refracting and coming out in a slightly different direction. So you see different colors. It's slowing down the light waves. So let's make some colors. Let's make some rainbow colors. Let's refract some light. So all you need for this activity is a CD, woohoo, and of course, a flashlight. And we're going to pretend that this is the light from the sun, and this is what the light is passing through the little grooves in our CD. It's going to reflect and refract that light in different wavelengths to create the different colors. So I'm not sure what this is going to happen with when I turn off the light in my room, but I'm going to try to project rainbows on my ceiling just from my flashlight, which is the sun, and my CD. You can almost see rainbows just when I'm reflecting it at the screen. Let's see. Okay, so you can try this at home. Maybe you can get, okay, I'm trying to bounce sunlight and get a rainbow on my back closet door. Well, I definitely got one on the ceiling, but you can't see that. But experiment with this. See if you can see all the colors of the rainbow and shine them around the room. That's the sunlight passing through. It could be, in this case, it's a piece of plastic CD, but moisture particles, that'll do that too. Light passing through will create rainbows. I'm going to try one more thing. If you happen to have a piece of white paper, I'm going to put that down on my table. Let me see if I can get a rainbow on my white piece of paper by refracting the light. Try that. Oh yeah, I did. Can you see it? I don't know if you can see that on camera, but I can see it here. It's really cool. It's a great looking rainbow. So sunlight comes in all different colors. It's very awesome. So try this at home. It's fun to play with in a darker room. Now, do you ever wonder why you can't see the stars during the daytime? Well, they didn't just go away. They're just kind of, and they didn't really disappear. We just can't see them. Why do you think that is? So now that I've still got the light off in my room, with this activity, all you need is a colander from the kitchen with holes in it. Whoa, that's reflecting off my screen too. And a flashlight. And you can try this in a dark room. So we're going to pretend that this is the starlight, and we're going to stick it underneath the colander, and we're going to turn on the flashlight and see if you can project points of light onto the ceiling. Okay, here we go. Whoa. Well, you on screen can see the flashlight shining through the holes in my colander, but what you can't see is the cool stars that I have on the ceiling in my den. Let me see if I can reflect them back to my closet door. Can you see? Oh, twinkle, twinkle. There we go. I do have some starlight on my, there we go, some stars. So then, let's say, you know, we're doing this and it's night, so you can see the stars. What happens when I turn on the sun when it's daytime? Ta-da! What happened? The sun shines so bright that you can't see the stars. They're still there, but I can't reflect them off my ceiling or my closet door. It doesn't work. The sun is too bright, and so you only see the sunlight. But that's not the only reason that you can't see stars during the day. Here's something else that you can try, and we'll set it up here with a bigger flashlight. This is a mega flashlight. Don't need my colander anymore. All I need is a piece of paper, and we're going to take and fold the paper in half, just like this. All I need is, and on one half of that piece of paper, we're going to take a pencil and put some holes in it. I did it already on this one. See how I put some holes in it? I did it in the shape of the Big Dipper. Huh? But anyway, so you can do it in any shape you want. And I'm just going to poke some holes with my sharp pencil lead, like that, through the paper. You can do this. Whoa. And sometimes when you do that, your holes close up because the paper kind of rips. But make sure it's a really good looking hole. See, I'm just going to make my holes really, really big. Okay, so I got a few holes in my paper. And there it goes. One side has holes, one side has no holes. So our Earth has atmosphere all around it. Look at that, our atmosphere, and it creates, you know, clouds and the air we breathe. There it is. So what happens when sunlight hits that atmosphere? Well, I think, what do you think? I think it's going to reflect. So we're going to reflect and disperse. So we're going to pretend that the side of the paper without any holes in it, that's going to represent the Earth's atmosphere. And the side with the holes is going to represent the starlight that we see. So here's what we're going to do. I have, whoa, just a minute. I have a big flashlight. That's going to be the starlight. And I'm going to put that right over here. Make sure that you can see it. And over here, just off screen, you can't see my lamp. That is a bigger source of light, and that is going to be the sunshine. Okay, so I'm going to hold my piece of paper right in between the two sources of light. This is the sun hitting the Earth's atmosphere. This is going to be the starlight right there. So I think I'm going to need to turn off the lights again, and let's see what happens. What happens when the sunlight hits the Earth atmosphere? Okay, so let me turn on the sunshine. Whoa! There we go. So you can see that the whole side of that paper lights up, right? Yeah. Okay, so now I'm going to turn on my flashlight. Just a second. Okay. There. Oh, wow. You know, you're going to have to try this at home because I'm not sure this is going to show up on camera. But anyway, I'll show you what to do. So sunlight hitting the Earth's atmosphere. And I'm not seeing any stars. Okay. Yep. Oh, so let me try something first. Okay. So now all my sunshine is out. Okay. So let's see if we can see stars. Well, you know, this flashlight is so bright. Maybe I tried this without the computer earlier and it worked. Let's see if I can do it with a littler flashlight. Okay, here we go. Oh, can you see the starlight through the holes that you made? Okay, the stars are shining. So now we hold those through the pages. Well, you can see when you're doing this at home, you can see the starlight shining through those holes. But then as soon as you turn on our sun, all you see is the sunlight shining and reflecting off the atmosphere. So try that at home. It doesn't show up on camera too well, but you'll be able to see it. So that is very, very cool. All right, so let's turn on the overhead lights again for a second. We got one last thing to do together today. So now that you know that a bright light like the sun blocks out the starlight, let's talk just a little bit about light pollution. Have you ever noticed that when you're in a city or maybe a parking lot somewhere around town that you can't see as many stars? Why do you think that is? It's because the light, the light that we make with all of our street lights and lights from our yard and things, all the light sources that we create as humans, that's what we see. We see the bright light and it reflects up into the sky and you can't see as many of the stars. So I've got a little street scene right here. Back up. And I've got, I'll show it to you first. There we go. Street scene. A city, a town. And I have got some little guys to sit on my street. Oops. And let's see, what do we need? We need some street lights, right? Okay. So I've got a light shining. Let's pretend this is a street light. There we go. And it's shining down. But what happens if we have a different kind of street light that points upward? Where's the light going? Up towards the stars, and you can't see the stars. Oh my goodness. So sometimes, light sources, they shine light out in all directions, like this light bulb, or way up where we don't need it, like this flashlight. But what happens if we point the light downwards? Then not so much light is going up to block out our starlight so that we can see it. And so if you also have a little cap or something on your street light, it prevents more of that light from shining up into our sky. So actually, we can prevent some of the light pollution by how we shield our lights. So if you have, we're gonna do this together. Hold on. Out goes the light. If you have a cereal bowl and a light source, see, I'm gonna use the big one. It's more fun. A big, huge, honking light. Okay, so there's that light. So if you have a great big light shining in your yard or on your street or from a window, all you need to do is shield it, and then boom, you can see the stars again. There we go. Big shield. So a little bit about light pollution. And I'm going to turn my flashlights off and my lights on again. And I hope that you get a chance to try some of these experiments with day and night. And I hope you get a chance to go out and look at some of the stars and just feel what it's like out there during the night. So, thanks for joining us on First Step Science, and we hope you join us again for this whole month when we're going to be doing astronomy each session. So, join us again. Bye. seen before? And here's where you get to make a choice. Was it a giant Tyrannosaurus Rex? And I'm just gonna stick some pine cones in my box, and then the fun starts. I just start rolling them around. The air rushing out of the balloon is gonna push that balloon up. So let's see what happens. All right, 1, 2, 3. Oh, wow. So that's how rockets kind of work. We are going to build 2 different kinds of rockets today.